Hello, good afternoon on a Wednesday. It is the coding train here. Oh, and why? Why might you be asking, do I have two train whistles today? I mean, first of all, why should any grown person on the internet have train whistles? I'm not really so sure, but apparently this is what I'm doing with my life, and so there it is. I am a person on the internet with not just one train whistle, but a second train whistle, albeit a slightly sadder train whistle. Let's give this one a try. Oh, actually, that's not so bad. So you might be asking, why do you have multiple train whistles? Well, thanks for asking. I am going to embark on a new adventure in learning how to use a laser cutter. In particular, I want to learn how to do laser etching. And I have this YouTube membership thing. And I'm about to relaunch all of the membership rewards, and one of which will be your very own laser-etched coding train whistle, which you can only get exclusively as a member of the coding train. Oh, the other thing that's quite exciting here is I have some new tricks. Let's see if this works. I have a new camera here. You can see my Stream Deck and iPad, but mostly I have this here because now I can show you this train whistle. So this is what I've been using for all these years, purchased off Amazon, and now I have about 150 of these in a box in my office, and I will be laser etching my own coding train onto here and mailing them out with the help of Sai, who is the Coding Train community manager, in 2020. So if you had never had a reason to join as a member today, before, you can join today. I also thought, I could do some more cubing, coding cubing with my beginner's method of solving a Rubik's Cube. Maybe I could talk. Do you think I could talk and solve the cube at the same time? Can you even see what I'm doing here? I suppose this probably isn't what I should be doing right now, but I am an amateur. I have a love and affection for Rubik's Cubes. I'm not sure why exactly. I just can't help myself. What am I doing here? I'm trying to solve it. I cannot solve and talk at the same time. It's much too difficult for me to do that. And all of you who are actual cubers out there are probably in so much pain right now watching me do this with my methodology. That is, but I've spent not too much time in my life studying how to solve a Rubik's Cube. I wish I had more time because honestly, I would like to spend all of my time doing that, which might just be kind of an escapist fantasy, a reason to completely leave the world and universe that we're in right now, which feels like I often want to do, but I shouldn't. I want to stay here. I want to be with you, the people, the people of the passengers, if you will, of the coding train. And I want to enjoy this Earth planet thing that we're on. I can't even talk when I'm not solving a Rubik's Cube. And apparently, while I am solving a Rubik's Cube, is a much harder. It is very hard for me to put words together. Do you think I could code and solve the Rubik's Cube at the same time? I feel like I just have to finish this now, but I can't stop talking. I guess I could play music. Oh, 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 oh. Cubing in the Cabana, coming soon? No? Maybe? Now, lest you think that's exciting, I will show you now what I've been working on. I will show you what I've been working on, which is my new 9x9 cube, which I am attempting to turn into a 3x3. You can see that so far I've solved the white center, the yellow center, the green center, and this morning when I was having my tea in the morning, I was working on the red center. I have solved this before. It took me about a week, little pockets of times here and there. So, maybe a little later today we'll work on this a little bit more. All right, now, I just wanted to show you my new overhead camera in case we have more things like this train whistle and stuff for me to show you. I have that. I also have up here in the top left, oh, wait, how come that didn't go away? There we go. I have up here in the top left of the screen a Streamlabs alert box. So I don't know if this is a useful, interesting thing to do, but I'm learning about the world. I'm like the old man live streamer. You're learning about all the young people's fancy tricks. And so supposedly, if somebody subscribes to my YouTube channel called The Coding Train right now, their name will appear right here. If they join as a member, their name will appear right here. And I believe a super chat, but I don't know how I feel about the super chats. Those make me uncomfortable. I'm very grateful and thankful for everyone's support. Some people were asking me about the mouse pad. How do I get this back up here? Overhead. There we go. So this mouse pad is a drawing of a house made by my daughter, who is now 8 years old. I think she might have been younger when she made this. It doesn't say on the back. I was hoping it would say on the back. But it's one of those things when your kids make an art project at school, and then as a fundraiser for the school, you can buy their art on like a mouse pad, and so I did. Okay, overhead off. Overhead off. So Kevin writes, I subscribed 5 minutes ago and it did not show. Well, 5 minutes ago, it should show instantaneously. So if you subscribed 5 minutes ago, was I live streaming? Was it up there? I don't know. All right, everybody relax. Let me test my banner here. I'm gonna make a little test of it. I've got a little test going. I'm gonna test subscription. Oh, you're right, it's not working. Let's fix this. This is the important thing that I must work on today. I turned off subscribers. Because that seemed like a lot of noise. Let me turn that back on. Copy. Oh, whoa, somebody just subscribed. It appeared. I don't know what I just did, but it worked. Now I don't know what I did, but it happened. Somebody subscribed and it appeared. That was very exciting. So maybe I don't need to fix it. Hold on, let me look at this here. Just everybody, just everybody. Sponsors, super chat. Hold on. There, oh yeah, so I think it's working. All right. Thank you, Akshay R, for subscribing to my channel. What's this from? I think it's maybe like is it a Futurama quote? I'm not sure. I like your ideas and I would like to subscribe to your newsletter. Maybe that's just from The Simpsons. I don't know. I'm getting a very loud, I'm hearing like a ding dong when somebody subscribes. Do you hear that, or is it just coming out? Probably just coming out of the monitor of this computer down here. Yes. So I think I agree. I think I'm probably going to turn off the subscriber thing. But new member. Let's see if that happens. EM Scofall, new member. Maybe, depending on your membership level, you might get a train whistle. It didn't show up. All right, I'm going to fix this. Everybody, hold on. All right, if I've done everything correctly, now it shouldn't show up anymore as people subscribe, but only if they join as a member. We'll see. We'll see if that works. Oh, technology. Okay, let's see. Okay, so I should really get to the business at hand, which is that I am here today to do one thing, and one thing only. I am going to attempt to implement the Minimax algorithm to create a AI. I don't know if that's really, sometimes you say the word AI and it sounds like, oh, this like fancy artificial intelligence robot thing, where really it's just an algorithm to pick the optimal move. But AI, it's sort of clickbait, so I put it in the title. An AI bot to play against me in tic-tac-toe. And as you saw from my Rubik's Cube solving prowess, I'm probably very good at tic-tac-toe. New members are joining. Are they popping up? Did the alert pop up? I don't actually see it. No. So far no overlay. I guess I'm just destined to never have this overlay thing work. Hold on. Ah, thanks for showing my email. Oh, wait a second. Wait a second. I am not logged in as the coding train. Oh, I'm such a dum-dum. Okay, hold on, everybody. I'm going to fix this. It's showing you an overlay for some other YouTube channel associated, associated with my Google account. I will fix this now. I now know what the issue is. I am the coding train. That is me. I am logging in. I'm going to my dashboard. I'm going to my alert box. I do not want to join Streamlabs University. Thank you very much. Alert box. Dink, 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 dink. Copy. I'm going now to Open Broadcast Studio into the alerts property. I am pasting in a new URL. I'm hitting OK. I am going to, does it refresh automatically? I'm going to press this button. There we go. Coding Train has become a member. Coding Train has donated Super Chat. And you don't see a subscriber because I have that turned off. Okay, so now it should really work. I hope. Thank you, Humpty Dumpty, for joining. Where is my bell? I will ring the bell for your join. Don't fall off the wall. The bell, oh, it's in front of my face. This is the thing, by the way. I have a very special talent, which is to not see things that are right in front of my face. Thank you, Humpty Dumpty, and thank you to a new member, EMS Kofal. Welcome. You have the nice, lovely little this dot icon. Okay. So what else do I want to talk about? So before I do the Minimax algorithm and talk about what Minimax is, let me revisit the most recent video tutorial published on the channel, which was the ML5JS Train Your Own Neural Network. Now, if you watched the live stream where I made this tutorial but did not watch the actual tutorial video, this is one of the rare cases where you might actually want to watch this video, because after the live stream, I re-recorded it. The edited versions of things that are in a live stream always have, not always, but often have a little extra bits or some light editing to speed through and skip things. But sometimes I will actually come back and re-record an entire thing or an entire section if I got it really wrong. David Snyder's, it's like testing. Did it show up? Did it show up? Did it show up? I want to know because I wasn't looking. I was not looking. I didn't hear the ding. I think I would have heard the ding. Oh, it did. It did. It just was late. It did. It showed up late. So you haven't seen it yet. You mean you've seen it now if you're hearing me talk. But you have to remember that I'm on a 30 there's like a big delay here. Okay. Check this out if you're interested. I also, in addition to doing these live streams like you're watching right now, I will often live stream to members my different recording sessions if I'm doing extra material or some extra tutorials, not part of a live stream. And just yesterday, in fact, I had a members live stream where I recorded 3 more videos, all follow-ups of this one. So in this particular example, I did the data collection, training, and inference. And then the videos that will be coming out are looking at how to save the data that you've collected, how to save the model that you've trained, and then also how to implement a regression. So how to change this into a regression. Okay, so take a look at those. Let's take a few minutes to look at some of these community contributions. I should also mention, speaking of things, I have this keyboard that I'm using today because my butterfly, well, I think it's called the butterfly keyboard on this Mac, is just, you know, it's dead. It's like completely unusable. So I'm attempting to use an external mouse and external keyboard today, and hopefully that will improve things in terms of my coding and all of that. All right, overhead off. So let's take a look at some of these. So first, I haven't actually looked at these, so this is a surprise to me. Turn my screen brightness up a little bit so I can see it. Let's look at the self-learning neural network by Vlad. Okay. Oh, whoa, wait a second. So this is interesting because this looks like it is based off of my cars neuroevolution example, which I built during a different live stream. And only for Windows. So I guess it's just the executable and we could run it. Is this using ML5? Vlad, if you happen to be in the chat, I have a bunch of questions about this for you that I'm curious about. But I will move on right now to the next one. Neural network visualization after training, wait a while by Charlotte. Okay, I'm excited about this. So let's take a look at that. A, B, C, D. Oh, so this looks like it's just like my example. So I'm going to do some training here. Can you hear that? Are we hearing anything? Maybe there's no sound in this one. It's using color instead of sound. So let me do a bunch of B's, a bunch of C's. I would love a community contribution that thinks about a more elegant interface for doing this data collection. But let me do this, and I'm going to now hit T for training. And we'll wait for the model to train. So Simon is letting me know that I missed showing contributions for interactive drawing and teachable machine. I would be glad to look at those. Maybe I'll look at those at the end if I have time, because I want to make sure I get to Minimax. Did this train? Okay. So Charlotte's instructions say, oh, Charlotte did what I was hoping for. So we see like a heat map or decision map of all the different colors based on the training data. And it's kind of amazing how it actually ends up producing this like Voronoi-like tessellation. I should really try this again with a less obviously clustered data set. If you'll oblige, if you'll humor me, I would like to do this one more time. So I'm going to make the data much noisier in terms of where it is. Like I'm still going to kind of cluster it, but I'm going to spread out some, we'll make it a little bit more chaotic. You know, traditionally you would do something like what we're looking at here with an algorithm like k-means or a clustering kind of algorithm. It's interesting that we're using a neural network here to ultimately kind of perform the same kind of idea. Now, I expect the loss won't be as low because there's going to be a lot more errors. It's going to be a lot trickier for it to figure out how to train this model, but let's give it a try. The loss is definitely going down. That's a good sign. I'm looking for my heat map. Interesting. Oh wait, how do I do my zoom thing? I still have to use this. Are we seeing, it's interesting, it really is very consistent still. So I'd be curious, I wish I had hours to unpack and do a deep dive into every single one of these examples. I'm curious why this took so long. It's a very slow process if every single pixel was passed into the neural network and classified one at a time. ML5 will allow you to pass in a batch of data and get the classifications for all of them. So Charlotte, if you're watching, I don't know that you are, take a look at that. That might improve the speed, but this is a tricky one. Or maybe using promises and some kind of like asynchronous something or other could help too. All right, let me close this. What else we got here? We have now regression based on note frequency and color predictor. Okay. So let's see what. I'm not sure if I'm supposed to be. Oh, I like this. I can paint with it. That's really nice. I can paint. So this is a nice improvement on the interface. I don't know how many options there are. Let's try this and hit T. Train this model. It's a little weird that I don't see a graph at all. Oh yeah, so Simon makes a good point. I said k-means in the sense that k-means will find the clusters without the labels. So I think I was conflating some concepts there and just sort of like thinking about the visual relationship between that example and k-means example, but it actually is quite a different thing, so thank you for correcting me there. All right, what's just happened? I don't know. So something has gone wrong here with this example. So I don't think I'm able to effectively debug this right now, but thank you for the submission. And Darshan, if you happen to be in the chat, let me know. So much discussion about Minimax and Q-learning and which should I use and what the spade, so much good stuff to come. Okay, so thank you for these submissions. Stay tuned, hopefully sometime next week, the follow-up videos for this will be released. But now I'm going to move on to the main task of today. And before I get started with that, what I would like to do, and hello to Zul from Indonesia. Thanks for watching. And CJ is here. Hello, CJ. CJ from the, I was going to say the Coding Train Garden, but that's not it. It's the Coding Garden. Wonderful YouTube channel. I would like to download this code and get myself set up with it. I think I'm going to work, outside of the P5 web editor because this is going to be a pretty complex problem for me to solve. So let me download this P5 code. And so for any reason you want to follow along, you can start with this starter code that I'm about to use. Go in here. Let me call this. Let me call this. I don't know how to use a computer with a mouse. It's like my hand is all the way over here. Look at this. It's crazy. My hand is all the way over here operating the computer. But look, I can type one character at a time, and they appear one character at a time. Go away, overhead. Desktop. And then let's open this with Visual Studio Code. Okay. Let's go over here. And let me run my terminal. And I'm going to go to desktop, Tic Tac Toe. I'm going to run a server and load that up in the browser. There we go. That's the example from before. Let's go here. And now, okay, all right. So here's the thing. What I would like to do is I want to make some adjustments to this tic-tac-toe example that I won't include in the final edit of the coding challenge, but I will do with you here right now. In a way, I want to simplify some things about it, just to make, I think, what I really want to focus on is the core Minimax algorithm, and I don't want to add a lot of complexity related to the game mechanics themselves. So I'm going to assume that there's only ever 2 players. And I'm going to say there's going to be an AI player, which will be an X, and a human player, which will be an O. And then I am going to, what I'm going to do is, let's get rid of this like available stuff for a second. And this like picking a random current player, that could be useful. Let's keep the current player, and we'll say that current player starts with as the human, for example. I'm going to get rid of this idea of an available array, just to simplify. This check winner thing can be the same. Next turn. So this was picking a random turn. So let me do this. I'm going to leave. Let me make the. Okay, so what I'm going to do is I'm going to add a mouse pressed function. And if the human player, oh no, if the current player is a human, let's get the index into the board. Let's get mouse x divided by width, mouse y divided by height. I'm going to floor these so that they're indexed. What I'm trying to do right now is just create a quick interaction where as I click the mouse, if where I click the mouse is an empty spot on the board, then I'm going to fill it in with my human marking, which is an O. And otherwise, if the human player if the current player is the AI, actually, you know what? I'm just going to make my turn, and then immediately, oh, this is silly. So every time I click the mouse, I'm trying to think through this, what I'm actually doing. I'll leave there's some extra stuff perhaps in here. So if it's a valid spot, then the next thing I want is for the AI to make its turn. So human make turn, then if it's a valid turn, then the AI should make its turn. And right now, just have it be random. So I shouldn't have gotten rid of that available thing. But I think I can just rewrite that by saying I can just look through all of the spots. This is silly because I already used I and J. K, A, B, C, D, E, F, G, H, I, J, K, L. I don't want to use L. Does anybody ever use L? Huh. X goes first. Huh. Thank you, Simon. I will correct that because I will have the AI go first eventually. And I'm here to break the rules. I'm going to use an L, by golly, as my index. And, oh, this is so, now I'm writing a whole extra algorithm that I don't want to write. Available, push I is K, J is L. I want a little object, no. Oh, no, let's just do this. K, L, make a little object, and then I want to, this is so silly what I'm doing. I should just do it in order, it's fine. Then I'm gonna say move equals random available, and then board, only if it's available, if board K, L is blank. This is so silly that I'm doing. I did not intend to write a whole new algorithm here as like a random AI, but it's what I'm doing. and then move is random, and then board move.k move.l equals the AI. And then the current player is the human. I think this current player thing is completely unnecessary, but that's fine. And once the human's made a valid move, the current player is the AI. And let's see if this does what I want to do. Okay, what? Players is not defined. Sketch.js, 109. If spot equals, what did I say, human was O, even though I'm doing it wrong according to Simon, and AI is X. Available is not defined, sketch 49, because I got rid of that concept and then added it back in again. Oh! I needed it for something else. Let's just do this. Let open spots is 0. And then if the board, I can use ij here. If the board, I didn't really think I was going to change very much about this example. ij, if the board is empty, increase the number of open spots. I will explain what I'm doing in a second, in more detail. Then, as long as there are no open spots, I can break out of the loop there too. So if there is no winner and there are no open spots, it's a tie. Otherwise, there's a winner. Boy, this algorithm is ridiculous. I should also refactor that, but I'm not going to. Let's see. Next turn, 139. I'm not doing a turn in the draw loop. I shouldn't use the draw loop at all, but I'm going to be lazy. 139. Oh, I'm missing an end curly bracket. W is not defined. I made up this variable called W, which somewhere I must use, have thought I created it because I use it everywhere. Like in draw. Ah, here it is. It's not a global variable. So let me make this a global variable. But I'm going to have to create it in setup because the width and height don't exist. And also it's a square, so I don't need separate width and heights. But what are you going to do? Oh. Oh. Ha! I win! Ha ha! I win again. By the way, the optimal move I think is to go in the corner. X wins. What? No, I won. There's a bug. We'll fix that another time. Ha ha! I won again. Okay. So this is what I wanted, except there is an issue of. Okay, so I have a. Let me do this. Let me do this. AI move. We make that a separate function. Everything's going to be fine. And then I'm going to call this AI move, which was actually called like next turn before, so I don't know why I'm changing it. And then this, I can have my trusty I and J back. Oh, thank goodness. And then, oh, I'm gonna do something even better. By the way, in case you're wondering, the whole point of this is I'm going to change this to Minimax. So I want to start the tutorial or the coding challenge from an AI that just picks a random move and then have it pick the optimal move. That's what I'm doing here today. So if that interests you, stick around. If I can get this to work, I'm going to be quite shocked. Right, this was it right here. I already have this. It was called next turn. So I could just call this next turn. That's what I had before. And you know what I'm going to do? I'm going to put this in a separate JavaScript file. I'm going to call this minimax.js. And I'm going to have it there. I'm going to add this Minimax. I don't like having these CSS files for no reason. It's just extra noise. And so now this should be next turn. And then, so that X really goes first, we'll have in setup X go first. Okay. Now, we will now have an official competition. Oh, new member, Goober Genius. Is it called a goo? I just watched Into the Spider-Verse. Sorry, this is like totally non sequitur, which I absolutely loved. One of my favorite. I did not expect to love it as much as I loved it. But isn't the thing called like a goober? No, goog? I can't remember. There are 512 people watching. Me about to attempt to play tic-tac-toe against the computer. All right. I'm going to get you, X. Ooh, good move. Good move. I'm going to go here. Dun, dun, dun. Oh. A bug. There's a bug. And the bug, if X goes after me and wins, then X is told it wins. Oh. Let's try it again. Go here. Go here. Yes! In your XAI, man ho, new member. Mwah, thank you, welcome, thank you for joining. Boy, this overlay thing really brings on the new members. Or maybe it's just you're excited about this train whistle that I'll be mailing to you. Okay. Do you already have a method to check if someone won? Yes, I do. I will not be doing, so I do wonder if I do this particular coding challenge with Minimax, if that will lay the groundwork for future videos as I look at more learning styles, and Q learning being one of them for reinforcement learning. Okay. Could you check? Yes, I certainly could check the win condition after each. I don't feel like correcting that right now. That's just going to be a bug that I'm going to leave in there. But I am now going to get started, and I'm going to need heavy use of the whiteboard. So let me just test something here, because I think diagramming the Minimax algorithm, I'm going to want to use multiple colors. So I have not coded this before, but I did do some reading on it and thinking about it, and I drew some diagrams on a whiteboard in my office. So I'm somewhat prepared for this, which I'm sure it will all go horribly wrong anyway. I'm just writing on the whiteboard up where you can't see it to see if these markers work. I have a blue, I have a black. This is probably going to be somewhat of a long one, and I have a green. Okay. So these all work. I want a red also. Ah. The red's okay. Let's try this red. Better. All right. All right. I'm going to turn the overlay off because Deepak is suggesting there's a number file video about tic-tac-toe. I did not realize that. I will have to take a look at that. Q Shrod is asking, won't you need to fix the winning condition because that might mess with the training? I think it's going to be okay. The issue is that I'm allowing 2 moves to happen at once, and when I'm not actually, there's no training going on here. I'm just doing a search basically for the optimal move, and I assume I won't have that problem. Add a set timeout to next turn. All of these things are very good ideas. Oh, I like that, a little delay. Okay, I'll think about that. But I'm not going to do that right now. So here's the thing. I want to stick to the pieces of this that are relevant for Minimax. In that sense, I'm not going to worry about the interface and how the game is actually played and that kind of thing. All right, so give me a minute here. I'm about to start. But before I begin, I'm going to tell you about today's sponsor, the random numbers. No, that's something. I don't have a sponsor for today's live stream, so this is a nice opportunity for me to just like goof off. I'm going to tell you about today's sponsor, numbers. Today's coding train is brought to you by 91,242, 53,474, and 34,963. Thank you, random numbers. So Amr writes in the chat, I was hoping to apply this algorithm for more challenging games like chess. And you can. And maybe we can have a little discussion about that after I get through this very basic scenario. But I'm going to do hopefully what is a fairly simple, I don't know about simple, but basic scenario. Okay, where are we? 1:45. Am I really 45 into this? Oh my God. 45 minutes into this? Okay. All right. Okay. Oh, what's going on here? There we go. Oh, alpha beta pruning. Yeah, heuristic. Oh boy, so many things to discuss. I'll come back at the end to talk about those things. All right. Hello and welcome to a coding challenge. Tic Tac Toe again, but no, wait. Oh wait, no, I'm live streaming. So I've kind of, this thing has happened where sometimes I'll have these recording sessions which are member-only live streams where I really allow myself to start over like 15 times. And part of my reason for doing that was so that I would stop doing that so much during what's a more public live stream. And unfortunately, I'm not able to switch that muscle off. But I really want to attempt to not start and stop so many times, but just go with it. And Mathieu, Coding Train Editor Extraordinaire, will hopefully make this all wonderful and easy to watch in about 30 to 45 minutes, which I think is my target for this ending up as. Usual Coding just wants me to see their comment. I see you. I see you. Hello and welcome to Coding Challenge Tic Tac Toe, the Minimax algorithm. So you might remember me from my Coding Challenge number 149, Tic Tac Toe, where I made a very basic, somewhat, what's the word I'm looking for? Messy and spaghetti-like, where I made a very sort of like a big mess out of Tic Tac Toe. But I made a working version of the game, which I have running here in the browser. Now, I made some very slight adjustments to where I left off in that last video. So if you haven't watched it, you could go back and watch it. But it's a basic version of Tic Tac Toe. I want to start over so badly. Rocket landing simulation. I totally want to do that, DT6. No more starting over. No more starting over. Just my last time, please, please, please. I will put my overhead camera on and I will look at you from close up. No. If you let me do it. Well, I guess kind of dizzy. All right. Because I just want to code this, and I have to stop doing this. Last time. I swear. You're very kind. You are nice people. Woo. All right. Hello, and welcome to a coding challenge, Tic Tac Toe. Oh, with the Minimax algorithm. That's why I'm here. Because I made this other coding challenge, Tic Tac Toe, where I created a kind of a big, it was kind of a mess if I'm being perfectly honest, but I made a working version of the Tic Tac Toe game that just played with 2 players picking random spots. So since then, and you can check one of my live streams if you want to find where I did this, I made some adjustments to it so that I could, as a human being, play the game. So right now I'm going to play the random computer picker. I'm gonna go here, and then I'm going to block X. And I'm going to go here, and ha-ha, I win. O wins. So what I have, the adjustment that I made is that I added a mouse pressed function where I find where did I click, and I put my human variable, which is the letter O, onto the board, and then I call next turn, where next turn picks a random spot in the board and makes that the AI spot or X's spot. So the whole point of this video is for me to implement something called Minimax, which is an algorithm, a search algorithm, if you will, to find the optimal next move for the AI. I mean, I could find it for myself and then I could implement it, but the idea is I want this player, the computer player, to beat me at the game, or at least tie, to play a perfect game. And tic-tac-toe is admittedly an incredible simple, this will be an edit. Tic-tac-toe is admittedly an incredibly simple scenario, and we don't necessarily need Minimax. We can probably just memorize a few key principles of how to play. But I think it's a good demonstration of the Minimax algorithm, and if I can get it working, which I really hope that I can, then I can, at the end of this video, I can kind of discuss how you might take that into more complex scenarios. Even something like chess, potentially, is a game that you could use the Minimax algorithm with. Okay, YouTube reminder fail. What's that? I don't know what that means. Probably something that I did. Okay. Oh, that's just TMC joining. The reminder probably. All right. So let me go here. Go here. All right. Mathieu, maybe we can replace these later with clips, but I'm just going to let's look at, no, this is Geeks for Geeks is the one. Is this a reputable site that I should feel happily, yeah, stop. I'm not interested. Okay. Let me go here. 1. There we go. Okay. No, go away, ad. Stop. Go away, all you ads. You're not paying me. You don't need to show up on my live stream. Okay. Actually, Linode is technically not of today, but as a sponsor, go to linode.com/codingtrain20 for your $20 off coupon. You know, not a sponsor of today's live stream, but a previous one. All right. I just want to reference these. If you want to learn more about the Minimax algorithm, I would suggest 2 resources that you can look at that I actually looked at before beginning this coding challenge. I haven't programmed this before, but I watched this video by Sebastian Legge that explains the Minimax algorithm, also something called alpha-beta pruning, which I'm not going to implement, but could be a good exercise next step for you. And I also found this article on the geeksforgeeks.org website, which has a 3-part series about the Minimax algorithm and how to apply it to tic-tac-toe. Now, those resources, if I'm being honest, are probably better than what I'm about to attempt to do, but I'm also going to take about a portion of this video to try to explain the algorithm in my own words and diagram it out, which hopefully will help me figure out what code I need to write. see, how do I do this? So I think I want to try to do this twice. Once with just a very general scenario, and I'm going to say that I'm going to draw a, what is wrong with this marker? I had such a good one before, I thought. That one's no good. Here we go, better. All right. What am I doing here? The Minimax algorithm is typically expressed or visualized as a tree. So we can think of the root of the tree as the current state of the game. Oh, you can't see that, can you? I usually put these little things, there's a little magnet to tell me where the top of the board is, but they were a little bit too high. I don't know if the camera position changed. Okay. Oh, is it tilted? Thank you for telling me that it's tilted. Let me try to fix that. I thought maybe it wouldn't be noticeable. Fortunately, I do have a level. I need to tighten this camera. Let's see how bad it is. It's actually not as bad as you would think. Oh, it's bad. It's way off. Okay, that's better. That's loose is the problem. I need to tighten it, but I think that's better. Looks better. Yeah. All right. It'll just be tilted for that beginning explanation. Mathieu can always probably, I mean, that's going to be, might be like a super annoying thing to do, but could fix it a little bit. All right. The Minimax algorithm is typically visualized as a tree. And the root of the tree is, you could think of as the current state of the game. So in this case, it's tic-tac-toe. And so this is the state of tic-tac-toe. Now, whose turn is it? Let's say in this case, it is the computer's turn. Wait, let's think about this for a second. Hold on. Better, thank you. Right, give me one more try here at this. Just thrown off there for a second. The Minimax algorithm is typically visualized as a tree. And the root of the tree you could think of as the current state of the game. So let's say I'm just going to draw a box here. This is the current state of the game. And maybe in a moment I'll fill this in with a tic-tac-toe board. But the idea here is that there is a player, the player that's trying to pick the optimal score. You can call that the maximizing player. So the maximizing player is trying to maximize their score to the game. Is going to make the next turn. So let's say that player just has two options. In tic-tac-toe at the start of the game, there are 9 options. But let's say there are just 2 options. That means we can have a tree going to the next state. Now, this Minimax algorithm is useful for a turn-based game. I don't know why that's there. This Minimax algorithm is useful for a turn-based game. So if this was the player's X's turn, now it's the player's, in this stage, it's the player O's turn. And the player O, if X made this turn, then O now has 2 options. And if X made this turn, then O now has 2 options. So I said that X is the maximizing player, and I erased that, and I'm going to put it back. O is the minimizing player. This whole system is designed to pick X's next turn, but we have to play out the future. And the future has O making turns as well. Then X, finally it's X's turn. So once again, we have the maximizing player going, and then O's turn, and so on and so forth. Now this only works if the game, well, not only works. With a game like tic-tac-toe that you'll see is simple enough, we can actually have this tree play out all the possible scenarios until one of the players wins or there's a tie. In other scenarios, you have to just use some kind of heuristic to make a guess as to like whether, well, no, what am I saying here? Oh, I'm wading into territory I don't want to wade into yet. This is very important. So let me rephrase that. So in the case of tic-tac-toe, it's a simple enough game where at any given point we could actually computationally play out every possible scenario until one player wins or there's a tie. In other games, like chess, for example, there's too many possible outcomes, and we have to use some other methodology to figure out when do we stop this tree? How far into the future do we look? But fortunately for us right now, that's not an issue we have to deal with. So eventually, at some point, after one of these moves, the game is going to be over. And so we need to establish at any point when the game is over, when we want to stop going through this tree, what is the score? So for us, we could do this very easily. We can say if X wins, we're going to give it a +1 score. If Y wins, we're going to give it a -1 score. And if there's a tie, we're going to give it a 0 score. So let's say in this scenario here, I probably should use like, if I'm explaining this, should I just use more like generic scores? This is fine. I'm gonna stick with what I'm doing. Yeah. That's a nice tip, Simon, to draw these as different. That's usually what's done, to draw these as different icons, but I'm not going to worry about that right now. So let's use colors for. Okay. So using these scores, let's say, so using these scores, let's say if X makes this move, O makes this move, and then X makes this move, X wins. So there's a +1. But if X makes this move, X makes this move, and, if X makes this move, O makes this move, and X makes this move, it's a tie. So if that's the case, I see what. To make this a bit more legible, let me actually make these blue. So when it's O's turn, I'm going to draw these squares as blue. That will help us see. And we don't have too many levels here, but this will help us see. So X, this is X's turn. It needs to decide, should it make this move or this move? Well, X is the maximizing player. X is the maximizing player, so it's going to want to make this move. So that means we can take this score and put it here, +1. And I'm going to circle this with green, just so we kind of see it as it's a winning state for X. Now, what if X makes this move, O makes this move, and then X makes this move? Well, maybe in this case, O wins. We get a -1. But if X makes this move, it's a tie, and so we get a 0. So which one would X pick? It's going to pick 0, right? It wants X is the maximizing player. If we're going this way, it's going to want to pick the move that yields it the better outcome. In this case, tying is better than losing. So this now gets passed up here, and it gets a 0. So what's interesting now is, remember, O is the minimizing player. So which move is O going to want to pick? O doesn't want X to win. So we're assuming we're playing against a player that's making optimal choices. So O, minimizing, would pick this move. So this would now have a score of 0 in it. And I realize it's kind of confusing, the zeros and the O's. So that's a 0 here. Okay. Now let's just fill in some other numbers just to do this more quickly. Okay, so so in this case, X to maximize would, sorry. So X as the maximizing player will want to pick the move that gives it a +1. X as the maximizing player will want to pick the move that gives it a 0. Oh boy. Oh, this was a bad example. Let me redo that. What do I want? I need something that's going to be different here. Let's have it win. So it's got to win both of these, basically. All right, so let me try filling this in with some other values. 1, 0, -1, 1. So X as the maximizing player is going to want to, if it's here, pick this move so that it wins. If it's here, it's going to want to pick this move so it wins. O is the minimizing player, but doesn't have any better options. The minimum is still just 1 out of these two. Picks this. And now X can make its decision. We're done, right? If every single possibility is explored, then X knows that this going this way will produce a better outcome than going this way. So this is the move that is selected. And this is done over and over again. Top right of the diagram shows Y instead of O for the, yeah. Ugh, I don't know why I put a Y there. That should be an O, not a Y. I don't know why I put a Y there. I think I should try this explanation again. I think I should actually just do it with tic-tac-toe. I was thinking I was going to do it twice. How do people feel about that explanation? I feel like maybe I want to try it again. The thing is, I was thinking about describing it more generically, and then I was going to actually do tic-tac-toe. But I think it would actually work just to do it with a tic-tac-toe board. And I would give the tic-tac-toe board like initial an initial state. Yeah. I mean, I definitely want to get to coding this. Please do it again. Yeah, do it again. There was something like inherently wrong with that explanation. I just, I don't know how helpful or useful it is. I don't think I'm going to do pruning. I'm going to erase this, though. That's for sure. You know what? I think I'm going to, well. Okay. I think I'm going to actually just do the X. Yeah, it's confusing that they're both 1 and 1. I think I'm actually going to do the, I'm going to explain it again, but I'm going to use an actual tic-tac-toe board because I think that'll be more clear. I think actually having the theory of it is interesting, but it's not that helpful right now. Write it lower. Okay. Yeah, and then Amy is suggesting try to explain it with chess. Let me try doing it just, I also think like why do it twice? I want this video to not be super long. And the live stream will always exist. So let me try doing it again. So I'm going to act. Acting. Thank you. Acting. I'm going to act as if I just explained to you the Sebastian Leg. Is it leg or lag? I think he told me this. I think it's lag. As I've just referenced those. Okay. So those two resources are probably your best bet for learning about the theory of the Minimax algorithm. I'm going to bypass that and just show you how the Minimax algorithm is applied specifically to tic-tac-toe, and I'll link to those other resources in this video's description. And hopefully this will give you a sense of what the Minimax algorithm is. So the theory of the Minimax algorithm is that the Minimax algorithm is typically visualized as a tree. So there's the root of the tree is the state of a particular game. I said I wasn't going to start over, but yeah. Yeah, okay. So those resources are probably your best bet for learning about the theory of the Minimax algorithm and how it can be applied to a wide variety of scenarios. But I'm going to look at the specifics of tic-tac-toe, which is a great starting example because it's a simple enough game that I could actually diagram out all of the possibilities, which even if that's computationally possible, is very hard to diagram. And there's lots of scenarios where you couldn't even compute all of the possible outcomes, all the possible all the possible future moves of a game, and chess is an example of that. So Minimax is typically visualized as a tree. So the root of the tree is the current state of the game board. So let's see, I'm trying to think of, I did this earlier today, and what's going to be a good thing like this. I want to leave 3 moves open. But I also want to leave it possible for somebody to win. So whose turn is it? It's X's turn. No, this is bad. Let's put O in the middle. X, X, O. I mean, I can make it so that O is going to win. That's sort of the point. I should make it that X is going to win, but not on their first move. Let's try this. That's X's turn. So X, O, X. X, O, X. O can't win. Well, unless X goes here, then O can win. All right, this will do. I think this will do. I think this will do as a scenario. Can you see this? Yes. It's very hard for me to see what's visible being recorded. So I've drawn a configuration. So I've drawn a configuration here of the tic-tac-toe board midway through the game because I don't want to start at the beginning where there's so many possibilities that I couldn't diagram it. So right now it's X's turn, and X has 3 possible moves. So I could express that in a tree diagram as move 1, move 2, and move 3. So let's take a look at what I mean by that. Let's say move 1 is over here, X would win. Oh, that's the point. Audio is very low. Is that really true or just one person? Probably one person. I'm going to use a blue marker so you can see the new moves. So let's say one possible move is X going here. Let me diagram out the next 2 possible moves. Another possible move is X going here. And another possible move is X going here. So we need to look at each of these and determine, is the game over or is it continuing? So only in this case is the game over. And in this case, the game is over and X has won. So I'm going to mark this green for the state of X having won the game. Now it's O's turn. And for each of these spots, O could has two possible options. Do the next two. All right. So O could go here, or O could go here. O could go here, or O could go here. And look at these. In this case and this case, O has won. Remember, we're trying to solve for the optimal move for X. X is making the first turn. So this means I can mark these where O wins as red. As like those are bad outcomes. Oh, wow, look at this. X, there's no tie. This is a scenario where there's no tie. I kind of meant to come up with a scenario where there would at least be a tie, but c'est la vie. The X is in the wrong place on the second board, says Leo. Oh no, I'm gonna have to do this again, aren't I? This is so hard. I'm so bad at this. Why does anybody watch me on YouTube? I'm like the worst at this stuff. The X is in the wrong place on where? The X is in the wrong place on the second board. It should be down one. Which is the second board? This is right. This matches that. This matches that. This matches that. This matches that. X, 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 S, X. What? I don't see it. Can't see the red marker very well. Bottom right. What? I'm going crazy. Are people trolling me here? I know Leo isn't. The bottom row, second to the left. Oh, this is the left, second to the left. I don't think so. Are you thinking that it's supposed to go like this? This is a terminal state. It's correct. Okay, it's correct. So Leo, I'm assuming maybe you made a mistake by thinking this is somehow connected to this, or it's not. This is a terminal state. And the red marker apparently is not visible. Let's try this. All right. So while these now are not terminal states, there's only one possible move. Whoops. Sorry, too many markers, and some of them don't work. What time is it? Ooh, 2:20 already. Oof. So while these are not terminal states, there's only one move possible for x. So I could draw an arrow and put that down here, but ultimately I can just consider this as x has to go here. So these you could consider as terminal, and in which case x will win. Oh, run, shoot. I think I might want to do this again with a different starting configuration. Now you see that I've visualized all the possible outcomes of the tic-tac-toe game based on this starting configuration. So how does x pick which path to go down? Where we can see here that the goal is for x to win the game, to get to here, here, or there. How does it do that? And the way that it does that, by the way, spoiler alert, this is the move it should pick. It should just win instantly. But the idea of the Minimax algorithm is if we can score every possible outcome, those scores can ripple back up the tree and help x decide which way to go to find the highest possible score. The nice thing about tic-tac-toe is there's not a range of scores. The endpoints are either you won, you lost, or you tied. So we could say something like, if x wins, I could have a score of +1. And typically in most examples, you'll actually see people, well, let me just, I'll come back to this later. So I could say if x wins, it's a score of +1. If O wins, it's a score of -1. And if it's a tie, it's a score of 0. So in other words, we could give this a score of +1, this a score of +1, this a score of -1, this a score of -1. And this a score of +1. But we've got an issue. I'm trying to pick between this option, and this option. These two don't have a score. How do I pick their score? Well, I can pick their score based on which one of these would be picked. But who's picking these? This is why it is called Minimax. Oh, that you can't see that at all. This is why the algorithm is called Minimax. Because we have two players, each trying to make an optimal score. X is what's known as the maximizing player. So to go from here to here, it's X's turn, and X is maximizing. But here, it's now O's turn. It's O's turn, and O wants to win. And O wants to win. X can assume that O is going to play their optimal move. Now, you could have a situation where your player doesn't play optimally, and that's something you might have to consider in terms of game theory. But in this case of the algorithm, we can assume that O is going to make the best possible move. I mean, if it makes a worse move, that's only better for us anyway, so it's all going to work out. So O is what's referred to as the minimizing player. The minimizing player. So O has the option of picking -1 or +1. -1 or +1. Which one is O going to pick as the minimizing player? The option to win. So we can then take the best outcome for O, the minimizing outcome for O, and pass that back up. Here's the score. And the same thing here. Now, X is the maximizing player. Which one of these is it going to pick? -1, +1, or -1? These are -1 because even though it could win here, if X goes this way, O is going to win. if X goes this way, O is going to win, if O plays optimally. So this is the way to go. And this scenario is, albeit very... This scenario that I picked might not be the best demonstration of the idea. In fact, there's no ties here. There's only 2 turns being played. So maybe what you might want to do is pause this video and do the same exact diagram, but have X and O with 2 starting positions and see if you can diagram that whole thing out yourself. If you do it again, you could try this configuration, X, O, 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 X, X. I have to say, I'm quite proud of this diagram, even though it didn't really work out the way that I wanted to, and I should have planned this in advance. And probably whatever I did, like I posted on Twitter, what did I do when I did this earlier? If I go to my Twitter page, yeah, I can look at this image. O, O, X, O. Oh, I didn't put anyone in the middle. So this is what I did before. So I guess this worked out a little bit better because there's a lot more. There's no terminal point at the first move. Is this what kind of like what Violet suggests? X, X, O, O. Oh, interesting. People telling me it was a good explanation. Okay. Maybe I'll just show this really quickly. Yeah. You know what I'm going to do? I'm not going to explain it again, but I'll just really quickly redraw it, and we can do a fast forwardy thing. All right? Let me try that. So let me go back to here. I say it's fine. All right, I'm just going to leave it. Let's move on because I got to code this. I don't have infinite time, so I'm going to move on. I appreciate everybody's thoughts. Okay. So how could we possibly do this? So how do we implement this in code? So that your first clue should be the fact that this is a tree diagram. Anytime you see a tree diagram, typically speaking, a recursive algorithm, a function that calls itself, is something that will apply. And this case is no different. I want to call Minimax on this board position, try and then loop through all the possible moves and call Minimax on each one of these board positions, loop through all the possible moves. If I ever get to an endpoint, return the score and have that score backtrack up or ripple back up the chain. So let's see if we can write the code to do this. I think I can, that's fine. I'm thinking about how to do this. Okay. 2:20. I think I can get this done in an hour. Okay. So this here is the place where I want to write the new code. Currently, a move is chosen by picking a random available spot, and I no longer want to do that. So I'm actually going to change the name of this function to best move. And I don't need to worry about this, what's available. I just want to actually look at all the possible spots. So basically, I just want to know, is the spot available? If the spot is available, now I want to call Minimax on this particular board. Wait. Yeah. Yeah. If the spot is available, I want to try going there. So I'm going to say board, ij is the AI player, and then I want to call Minimax on the board. Why do I want to call Minimax? Because I want to get what is the score. So I want Minimax to return to me. I want Minimax to return to me the score for this particular move. Now, it's going to have to recursively check these two spots, but we'll get there. We're getting there. Ultimately, though, I need to figure out which one was the best. So I need to keep track by saying, like, the best score is negative infinity. I can't spell. Was never the keyboard all along. And if score is greater than the best score, then that's the new best score. And the best move is this particular ij. Right? It's an object with that I and j. Yeah. And let me declare best move, and then move So again, I haven't implemented Minimax yet. I'm just getting the basic idea down. For this turn, I need to start by looking at all the possible moves, get the score for those by calling this mysterious Minimax function that I'm about to write, and find the best one, then apply that move. There's a bit of an issue here, though, because I am actually placing the AI character. Sorry. Yeah, it's being pointed out in the chat. There's a big issue here, though, because I'm replacing. There's a big issue here, though, because I am changing the global variable board. I am altering the game. I am moving x to that spot and then moving x to the next spot. So I could make a copy of the board, but I think an easy way to deal with this would actually just be to undo it. So right afterwards, I'm going to just quickly undo that move. So let's write the Minimax. Okay. The next step would be to write the Minimax function, to really write the algorithm itself. I kind of want to know to see if there's any errors here. So actually what I'm going to do is I'm just going to put a placeholder function in, Minimax, which receives a board, and then I'm just going to return the score of 1. So Minimax is always going to return the score of 1, meaning it's not going to be able to pick. It's just going to, they're all going to be a tie, so it's always going to pick the first one. But let's see how that goes. Next turn is not defined because I called it best move. Sketch 23. And it's in one more place here in setup. Okay, well, it went there. Watch, it's going to go to the next available spot, to the next available spot, to the next available spot. So you can see this is working. It's working in the sense that the algorithm is making a choice, but no matter what, it's always just going to go in order of the board. X1. Function is named best move as well as the variable. Thank you for that. There's also a big issue here, which thankfully no major problems happened, but I named this function best move, and then I created a variable inside of the function with the same name, which you can always run into trouble. So let me actually just change this to move. Sort of by definition, it is the best move. Make sure this still works. Okay, right. X is just picking straight down. Okay. Yes. All right. Now the hard part. I need to write the minimax function itself. So one thing that I've skipped here, which is typical of a minimax algorithm, is I would also keep track of the depth, because ultimately I could want to consider like how long is it taking me to get somewhere, what is the depth of the tree that I'm on. So that's something that you'll see often within the algorithm implementation. So let me add that. So I add an argument depth here and then give it a 0 at first. Oh, you know what? I need another really important argument. This is a turn-based game, and the algorithm is going to behave differently whether it is the maximizing player's turn, X, or the minimizing player's turn, O in this case. And again, you could have more than 2 players, or there could be a lot of weird stuff going on, but that's ultimately what I need here. So let me also add is maximizing. And this here would be true. Right? So I want to perform minimax on this board with a starting depth of 0, and the first move is the maximizing player. All right. So let's say I'm maximizing. What do I want to do? Actually, what I want to do even before this is check to see if somebody won. So I'm pretty sure I already have a check winner function. That's something that I wrote in the previous coding challenge. Let me double check that. Check winner. The winner is null. And then by the end, it returns a tie. It returns null, a tie, or the winner. So the score is, and let's make a little lookup table that's basically exactly what I wrote here. If X wins, it's a 0. If O wins, it's a -1. If it's a tie, it's a 0. All right, so this is my lookup table for what the score, then, and again, it's a very simple scenario. There's only 3 possible scores. And the score of the result is, okay, well, if the result is not equal to null, the score is the number associated with this particular, oh, it got rid of those. I didn't need those quotes. Visual Studio Code just cleaned that up for me. Thank you very much. The score is based on whoever won, and then I can return that. So this would be the terminal condition. If I am calling minimax on this particular board configuration at this particular depth, and it's an end state, if it's a terminal state, just return the score. That's what I'm supposed to do. Otherwise, I need to go through and pick the maximum. I need to go through all the possibilities again for the next player. Yeah. Yeah. if it's not a terminal state, if it's not this state, and I can't just return the score, I need to check all the possible next moves. And by the way, I got this wrong. So I got this wrong, actually. The next move, right, this is the AI player trying a spot, their move. So the next move is actually not the maximizing player. This should be false. But I'm going to write this as if it is. So if it's the maximizing player, I can copy paste that from above, check all the possible spots again. If it's available, try. Now that's the human, right? Oh no, this is the AI. I'm confused because currently in my brain, the way I'm stepping through this, it's not the AI's player turn. I'm confused because currently the way I'm stepping through this, it's in my mind, it's O's turn, but I'm writing the code for both, whether it's X's turn or O's turn. So for the sake of argument, it's X's turn right now. So I'm checking all of those spots, and then I'm going to say return. Oh, no. No, I need to check. I need to find the best move. I'm kind of doing what I did again. Is there a way for me to reduce the amount of code I'm writing? I'm not going to worry about this. I want to, once again, find the best score, which will be, in this case, negative infinity. And I want to say the score is the Minimax algorithm of the board at depth +1. And now the next player's turn is false, because I'm the maximizing player. And then I'm going to undo this, just like I did before. Why do I have to write this code twice? I'll think about later if I can refactor this to only do it once. And then if score is greater than best score is equal to score. And then after all of this, right? For loop, if it's an empty spot, boom, boom, return the best score. So this is finding the best score for all the possible next turns by the AI player. Or if it's not the AI player, if it's the minimizing player, we can do exactly the same thing. And again, maybe there's a way, and I'm missing a curly bracket. Yes, thank you. There's a curly bracket. So this is very important. There's a lot of ifs and for loops here. So maybe there's also a nice way to refactor this to make it more readable. But if it's the maximizing player, check all the spots, find the best possible outcome, and return it. But call Minimax recursively at the next future move. And then here, I'm going to start, right? The minimizing player wants to find the best score for it, which is the lowest score. So, and that's the human player. And if the score is less than the best score, and then return that best score. Woo. Oh, forget about this return 1. Let me see. Oh, this is very hard to look at. I'm going to stare at this to make sure on my curly brackets line up. If, for, and then return the best score. Otherwise, if, for, and return the best score. I think this might actually be good. Should we just try it? Error on line 33. Hold on. Being told there's an error on line 33. Return. Oh, this should be, look at this. So this is a huge mistake here. Return true. Why did I have that there? I don't know why I did that. That's return score. This should be return score. The whole point of this, and I don't even need a separate variable here. I can just say return scores result. right? So this is any kind of recursive function needs a terminal condition, it needs to exit, right? This function is always going to keep calling itself and calling itself Minimax. 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 I don't know what this extra code is in here. And Minimax. Okay. Oh, yes. Aha. All right, so there's also, Simon is pointing out something to me which is great, which I don't need this if statement to find the best score. The whole point of this and also this is a great chance for me to use the min function and the max function because it's the Minimax algorithm. So I can actually say score is the lower one, the minimum between score and best score. It's going to make it way easier to read. Thank you. And, oh no, but this one is max. Is max. And then this one, oh, thank you for this. I don't know why I didn't think of this. I'm sure it's in every implementation. Score is the minimum between score and best score. So this makes it much easier to read here. Okay. Let's try it. Let's try it. Why not? Caution to the wind. Okay, X went in the top left. That's definitely the optimal place to go. I'm going to go here. No, no, bad X. Bad X. You're not going in the right place. Yeah, I beat you. You're still going in order. Why are you still going in order? Oh, whoa! You're not going in order. You're making weird decisions. Oh, what's going on here? Oh, we're going to have to debug this. I thought like maybe for once in my life I actually wrote a complicated algorithm correctly. Oh, oh, oh! I see the error. I see the error of my ways. This has to be true, right? After the maximizing player's turn, it's the minimizing player's turn. After the minimizing player's turn, it's the maximizing player's turn. Okay. That's a good move, X. I see what you did there. Why can't you figure out to go there, X? Best score is max. Okay. Oh! Oh! No, no. Okay. This, I'm finding, this is, score is the new score. And the best score should be the bigger one, the maximum between score and best score, not score. This has to be this, because I'm returning best score, and this has to be this. Okay, okay. Let's see. I really should not continue to play this drum sound. Come on, X, figure out where to go. Okay, I'm going to go here. Oh, shoot, come on. It should really know to go there, right? Maximizing is the AI. Is maximizing. Minimizing is the human. Best score. Oh, no, 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 no. That's in the wrong place. It's in the wrong part. I knew, look, my brackets, bad brackets. I need to return the best score, hello, after I've checked all of the possibilities, meaning both for loops, the I and the J have completed. I got that right up here, but not down here. Oh, okay. I really think we've got it this time. Timpani sound. Ah! Yes. Tie! All right. All right, you. We're going to go into competition now. I'm gonna let you win by going here. Ah! So if I don't go in, if I go in a corner, yeah, if I don't go to the middle, it's always going to win. So X is always going to win unless I go to the middle, in which case it's always going to be a tie unless I make a mistake, and then it's going to win. But if I go to any other spot, X is going to be able to win because it's always going to, okay, this worked. Hey, that's the Minimax algorithm. Take a little, it's not even 3 o'clock. Amazing. I'm trying to think of how I want to wrap this up. All right. Oh, I'm so happy about this. Where did I go? Okay. All right. Now for a 5x5. Yeah, so let me make a list. Let me make a list of things you could try as exercises. The initial loop you wrote to check all possible moves isn't necessary. You could just start off with Minimax for the maximizing player on the current board. Okay, let's just think. Oh, in other words, I can say, but how does that give me, the problem is Minimax returns a score. So it doesn't return a move. So I'm not sure how I would do that. I'll let somebody smarter, somebody whose brain isn't as tired. I like to try to not compare smarts. Can I explain the algorithm? Bruno asked, can you explain the algorithm? Well, if you watched earlier in this live stream, I explained it so well. It was perfect. Nobody could ever have possibly misunderstood me. Yeah, I feel like this initial loop shouldn't matter, but I mean, sorry, this one. But I need a way to actually pick the move. And here I don't pick the move. I guess I could pick it in the Minimax. Oh, I could pick it and not undo it or something. I'm not going to worry about that. I'm going to let somebody I'm going to create a list of things. So, for example, try. All right. You could apply this to Connect 4, right? All right. I think I'm done. I think I'm done. The coding challenge is done. Okay. Yeah, okay. Thanks, Kobe. All right. I feel like I want to make a list of suggestions, even if it's just like a script that I'm going to follow. So let's think about what things people might do. 2 AI players, larger board, other game like Connect 4, animation and timing, and complex game that requires, oh, pruning. Alpha, beta, pruning. That requires a heuristic. Okay. So these are my exercise suggestions. Anybody have other ideas, or are these good, good suggestions? Three-player tic-tac-toe. Larger board. More players. Oh, depth. This is I could add. Okay. Faster is use depth in score. We can actually beat it. Go bottom right, then bottom left, then top right. Okay. Bottom left, bottom right, bottom left. Okay. Bottom right. No, it went there. It knows. I can't beat it. It knows. So Surzis, I will ask, what do you mean by complex game that requires heuristic? I will 3D. Oh, I could go first. The other thing is I could go first. So one thing that might be interesting for me to try here really quickly before I sort of finish off this challenge would just be to comment out the AI going first. So I know this is technically incorrect because X is supposed to go first, but let's see what happens if I start with a fresh board and I go first. So I'm going to go here. 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 Oh, a tie. Something became undefined. Oh, if I go last, I guess there's no move for X and I've got an error. So that's an English fix. Can I beat? No. I lost. Is there a way for me to beat? No, it's always going to go to the center. So there's no way for me to beat it. I don't believe there's any way for me to beat the AI player. It's a solved game because it's always going to go to the center. So I could try going here. I could go here, and the best I could do is a tie. Okay, yes, Simon, that one is counted in the larger board. Okay, tie or lose. Yeah, I could try. Starting with the center is not going to do me any good. The best move is the corner, I believe, but whatever. I mean, it's going to play optimally no matter what. All right, let's finish this. All right. So you've watched this coding challenge. Maybe you have a creative idea about how to make your own version of this, but I just quickly whipped up, thanks to the chat in the live stream, also some suggestions of things you could try. So first of all, what happens if you just make two AI players that just play against each other over and over again? Well, in that case, it's just going to be a tie every single time. It's a solved game, but that might lead to some interesting possibilities. One thing that I'm not using is using the depth in the score. So for example, if I go back to the code, and I change these to say 10 and -10, I could account for the depth, meaning I could have a higher score if I win more quickly than if it takes longer to win. Right now, I'm not accounting for that. So where in the code would you subtract out depth? That's something you could try. Certainly it would be interesting to make a larger board. So can you play tic-tac-toe on a 5x5 or a 7x7? The winning conditions would change. The optimal play would change. That would be exciting to try. I hope somebody does that. You could try more players. Like how would you have a tic-tac-toe game with 3 players? That's something you could try with a larger board. You could try another game. Maybe Connect 4 would work. That might be able to apply Minimax to. Just thinking about the interface, animation. Like right now, whenever I go, the next turn happens immediately. You could think about timing and that sort of thing. But then I always say high degree of difficulty, and maybe worth me coming back to in a future video at some point, would be these 2 last items. One is known as alpha beta pruning. Oh, 3D tic-tac-toe. Thank you. It's the case in a Minimax algorithm where sometimes you discover an optimal path and you don't need to check the rest of all of the possibilities. And that, okay, no. Alpha beta pruning refers to an aspect of the Minimax algorithm where you find an optimal path and you know that all the other possibilities are going to be worse, and you don't need to go forth and check every possibility. So you could research how that works and add it to this algorithm. It's explained in the Sebastian Lag video. Then there's this idea of games that you can't possibly compute all the possible moves. So you need some way, oops. Oh shoot, I messed up the camera a little bit, but hopefully it's going to be fine. Then there's the possibility, oh, where was I walking to? Oh yeah. I don't know where I was. Then there's the possibility, did I just notice that was out? And that's, I don't know. Right, yeah, okay, I think I was here. Then there's the possibility of a game. Let me take this out here. I'll put this back in. Then there's the possibility, shoot. Then there's the possibility of a game where the number of moves is so vast you couldn't possibly compute the entire tree. Chess is the classic example of that. So you need some heuristic or a way of an estimated guess of what the score could be with any given state. So one way of doing this, which I'm not saying is a good strategy, but a simple thing you could do with chess is you could add up the total number of white pieces versus black pieces. Then you could say like, well, the score is higher if the maximizing player has more pieces than the opponent. So that's one way of approaching it. So you don't actually stop at the end of the tree, but you just go some predetermined depth and then calculate an estimate and have that ripple back up the tree. So you maybe give that a try with a more complex game. Certainly other types of AI algorithms and neural networks could play a role at some point with how you make that estimate. But ultimately, that is something that would be interesting to try as well. One more idea that just came from the chat. So this is quite similar to the idea of a larger board, but instead of just a larger 2-dimensional board, you could create a 3-dimensional board. So tic-tac-toe that happens in a cube. I should just do that as a coding challenge separately myself. So hopefully you learned something, and maybe this algorithm that looked a little terrifying to you at one point now seems quite accessible and doable. Maybe your creative idea is not on this list. Please make your own version of this. Share it with me at thecodingtrain.com. There will be a link in this video's description with instructions for how to share it. If you don't know how to share it, just write a comment, file an issue. We, the Coding Train community, are here to help you. And I can't wait to see you in a future video. Goodbye. All right, I think I am done. Oh, by the way, the alerts, were the alerts going off? I guess not, because nobody joined. I didn't actually turn them off. All right, I'm kind of excited that that worked. I can't believe it, actually. Oh, the XKCD cheat sheet. Oh, I forgot about that. I did not show that. Mathieu, let's edit this in after the fact. Maybe we can capture and scroll this separately because this is really good. This is another idea. That could be great. One more idea which just came in from the chat. There's a wonderful XKCD cheat sheet that shows a map of all the possible optimal tic-tac-toe moves for X and for O. And this is really a beautiful visualization that's much better than the diagram that I made here. And maybe actually a project you could do is think about how to visualize the Minimax algorithm as it is happening. And there's maybe some just wonderful artistic or data science possibilities that could come out of that. All right, thank you for watching this coding challenge on the coding train. I'm so glad that you were here with me. I can't wait to see what people make with this. This was like a tough one for me. I was a little scared of it, and I think it worked out kind of okay. And I'll see you in a future video. Goodbye. Super chat. Final test. David Snyder. Woohoo! It popped up. Thank you so much. You're all too kind. Do Predator and Prey game. Yeah, so what I'm going to do next is who knows what. But I will remind you that the next videos to come out on the channel are things that weren't from a live stream, and they will relate to the neural network. Well, Simon was telling me to show some community contributions for what? The interactive drawing and teachable machine. Let's see if there's any teachable machine ones. So what's a little confusing is it would actually, in some cases, and this is a good question, this is a question for those of you who work on the Coding Train website, does it make sense for there to be community contributions for each one of these videos, or just with one of them? Just on this page in general, I don't know. But let's take a look at these. Let's see where they came in. I think I have a memory of looking at these. Okay, so none on this one. Oh, a whole bunch. Ha 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 ha. Ooh, theremin, rock, paper, scissors. Wow, look at these. Didn't I have a memory of looking at these now? You sure I didn't? I didn't look at all of them because I don't remember looking at Simon's Make 24. But let's sort of see. I remember looking at this one. Yeah, I looked at this one for sure. There's this one. Ooh, look at this. Oh, this is actually training with the KNN classifier. Cool. I like this interface. That is awesome. Great job. I really like this interface, that it's just sort of like in real time. So with KNN, you don't actually need to train the model. KNN is just doing a search for the closest one. Or the KNN, the K nearest neighbors, so that can be very effective. If you have a lot of sample images, it can become too big to deal with, but that's great. Okay, let's look at which one of these. Is there one of these I should look at? Let's try. Are they the same? Let's look at the second one. Use keys 1, 2, 3, and 4 to select a quadrant, then choose an operation using plus, minus, asterisk, and slash. Boy, oh boy. Ooh, this seems hard. New level 1 game. Wait, how is this teachable machines? Quadrant could be one of the 4 sections of the window. Use keys 1. I'm confused. Where is the teachable machines aspect, Simon? Although this is cool though. Level 1 I think is where I am. 24. So wait, I'll have to select a quadrant like this. Ooh, look at that. 1 plus 1, 4, 2. I didn't do this right. When am I trying to get to 24? Uh-oh, it's too late for me. Well, that wasn't right. The snake game contribution from earlier today is really cool. Okay. What's your other one? Make 24 a teachable machine. Aha! I see. Hold your hand in front of a quadrant to select it. That's cool. That's really cool. So the interaction is with teachable machine. So I'd have to train a model and then copy paste. Oh, and you get to put your model there. That is such a clever idea. Ah, I never thought of that. So what Simon is showing here, which is very, very clever, is that you could make a game where the interaction is based on a teachable machine trained model, but you could actually tell the user, go train your model, just give it these labels, and then paste the URL to your model, and now you can play this game. That's wonderful. So I'm not going to step through training it right now, but and the camera, of course, went off, because it is the coding train, after all, where the cameras go off. Now they go off if they overheat. Hopefully it's going to come back on. I'm going to have to refocus the camera. I'm going to have to refocus the camera with my trusty Elgato focusing device. I turned the fan on, which will keep it cool. I'm not going to worry about the focus too much right now. Okay, wonderful idea. Let's see. The snake game, evolutionary AI, and then theremin. Am I on the snake game? Let's take a look at these. Whoa! Oh man, this is everything I always wanted to make. I haven't had the time for. So this is one thing I've talked about with my evolutionary neuroevolution tutorials, is that sometimes you can't try a bunch of different players in a game all at once on the same game board. You have to run separate parallel simulations, and that looks like that's what's happening here in this one, which is really, really cool to see. Oh, thank you for this. Wild. This is by Alex N. And then the theremin here. Ooh. So this looks like maybe this is similar to Alexander Chen posted an interesting teachable machine music-y thing. I'm going to let this go. And then let's look at these audio ones. Make the sound of the animal game. Let's try this. Hi there, loading teachable machine samples. Brrr. 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 Rawr. 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 Ba, ba, ba. You think it's, can we see whether it's getting my, is there a console log? Cat. Waiting. Rawr. Brr. Anything I make apparently is a cat. I wonder if it's not actually getting my audio or something. Anyway, let me know if you could get this game to work. I love the idea of it. It's really fun. Because so many of them are like find the image and show it. I love this make the sound. Okay, thank you for this. I think I'm going to stop for today. I can come back to the interactive drawing ones another time. I guess I can look at those just to keep up with everything. Were there no, still no variations. So, hey everybody, this was a good one. Make a creative version of this. Share it with me. All right, I think I'm done for today. It is time to go off for Thanksgiving holiday here. Maybe I'll read you some random numbers. I could work a little bit on this No, I'm gonna. I have just a little bit more of this red side to do. Right. I just have a little bit more of this red side to do. So I did the white, I did the yellow, and I did the green. So I just have 2 rows of the red side to do, and it looks pretty doable. I feel like this is too much pressure. I'll do this on my own time. This is my my quiet enjoyment activity. I will read you some random numbers. I hope everyone has a nice, if you are celebrating this holiday, I hope you have a nice holiday. If you are not celebrating this holiday, I hope you have a nice rest of your week. If it is bedtime for you, this is perfect timing for you. 99,751, 58,785, 72,986, 2,488, 23,354, 80,275. I just thought of something really important. I have not made a new Coding in the Cabana video, and it is time for me to do that. And so I must, on a live stream, pick the next topic for the next Coding in the Cabana video. Now, I had a list, and I had the spinny thingy. I feel like David Snyder was helping me with this, but I don't know how I'm going to find it. Shiftman, GitHub Randomizer. I guess I could remake it. So let's go to that. I have way too many systems for keeping track of my topics, but right now, let's pick from a few possibilities. So there was this to-do list here, which was everything I'd hoped to do this fall, which as you can see, I got very little. I like to pick nature-y things for Coding in the Cabana. I feel like ASCII art. So let's pick some things. Okay, what was that other rose? Like the star rose, like there was the Mara rose. But when I looked at it, there was also with it like on the Math World page, there was like another star rose. So why not? I feel like that's not the best one to arrive at because, but I'll put it on the list, star rose. Marching squares? I mean, why not? That's not really a Cabana video though. That's more like a ASCII art. I don't know, you'll help me curate this in a second. I'll just put anything that's a possibility. Memory game. Oh, I love the idea of doing a memory game. Breakout. I feel like the game stuff I should save for here. Hexagonal grid. Whirly noise I definitely want to do. I want the I'm looking for like the nature-y pattern stuff. So Delaunay triangulation could fit into that. Yeah, marching squares fits because you can make nice, cool patterns with that, like this. So that works. What other noise algorithms are there? Anything else? Let's look at, I mean, hexagonal grid is kind of interesting. That works. Memory game could be memorizing trees and plants. Star Rose has very little documentation, might be hard to do. Yeah, it's also, I could take that out because it's basically very similar to the Mora Rose. Let's look at, because I might try to do one this weekend if I have some time. I think that I may have done a thing where I assigned a bunch to myself that I was kind of interested in. Autoencoder. A lot of these have been done now. de Rham curve, what's that? Okay. I like this. Why not? This looks good. I'll consider that. Have I really not done this? All right, sure. I feel like that's a thing that I've done, but I probably spelled that wrong. Yeah. Well, I've really got to go soon. Quad tree I did, load bytes, flocking, cost. I did so many of these, so I cleaned this up. Tic Tac Toe, tree response, ray tracing. Oh, no. Ulam spiral. Oh, yeah. This is something I talked about with Matt Parker from Stand Up Maths at one point. And isn't there I think there's a 3 Blue 1 Brown video on this as well. Okay. Ooh, there's some very large images suddenly in the Slack chat. By the way, when you I know you know this, I just have to mention it again. If you post post an image in the Slack chat, I have everything zoomed so I can see people's text, and it just blows up, and I can't really see what it is or see anything that anyone's written. Just so you know. Musical melody generator. I do want to do that, but I think that's maybe not a Cabana video right now. Plain Z curve. There's somebody on Twitter has been sharing a whole bunch of these with me. So what is, can you, I feel like I know what that means, but I'm not sure. Like this kind of thing? Like this kind of curve? Lyapunov fractal. Lyapunov fractal. That looks hard. But okay, why not? All right, well now I have too many things. All right, maybe this list is good now. If someone can explain to me what was meant by Z curve, I'm kind of interested in that. Where was I here? I lost the page that had my things that were assigned to me. Okay, here it is. This is it. Okay. Anything else recently that I haven't looked? What's this? Whoa. I feel like, whoa. All right, this I have to look into more. That does look really cool. Curl noise. Curl noise. Yeah, you had me at noise. Okay, this works for me. Curl noise. All right. 3D CA. Okay. Yeah, I'll do that. 3 Central Avenue. Okay. 3D cellular. I mean, I should probably be more specific than that, but. So that's the Z curve. I can't. Now, once again, I cannot see what's in the Slack channel. I'm going to try to. Z curve. All right, this is good enough. I'll put Z curve on here. Why not? We'll figure out what it is. All right. We are done. I'm now going to pick the next Coding in the Cabana video. All right, everybody, you ready for this? This is a big moment. These are all the possible things. Oh, trapped night, maze solving, all such good. No, you know. Yeah, Rubik's Cube Part 4, someday. That's on my list. Okay. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. What's it going to be? It's going to be the Z curve. Or the star road. Oh, the Z curve. Can I spin again? Do I get like one veto? I feel like the Z curve was like the thing that I... Let's look at what this is. Z curve. Well, this fits with the Cabana sort of theme. Three-dimensional curve that consists of a unique representation of a DNA sequence. Huh. Zigzag shape. Huh. Is this really what was meant? Fascinating. I know nothing about this. Huh. Well, what do we think? Spin again or Z curve? Is the wheel like, I mean, I can't violate the wheel. It's landed on Z curve. It's what I have to do. There's no choice. I can't spin it again. It's too late. Similar to a Hilbert curve. Spin again. I can't spin it. I'm not going to. I mean, I could have established some ground rules, which is that I could create a framework by which I am allowed to sometimes spin again. Simon says spin again. Simon, you're always so like big on the rules. I'm surprised you say spin again. Yeah, I don't think it means Z curve. So here's what I think it is. Give me a second to find something on Twitter. I'm just going to, I don't want to pull up something by accident that I don't want to see. I thought maybe it's this. Hold on, I found the Twitter feed I'm looking for. So this, I'm looking at Juan Carlos on Twitter, and I'm looking for, here we go. This is what I thought. I think we're going to make this the Z curve. Hold on a sec. So I thought Z curve meant something like this. It's because it's an equation with some Z's in it. And then a bunch of different codes. This is very coding train-like. And there's like a bunch of them that Juan Carlos, this is Pons Campuzano on Twitter, has made quite a few of these. Here's another one. Yeah, see? What about some with complex numbers? See, look, Juan Carlos is even suggesting this for a future coding challenge. So how about this? Z order curve? Oh, that's what oh, there's also the Z order curve. Oh, I like that. Z order curve. So space filling curve, plotting complex functions. Yeah, so plotting a complex function, I mean, I've done some of that. But I also love this idea of Z order curve. This looks fun. Space filling curves. Okay, we've got some stuff to work with. Right, this could be interesting, right? So we'll discuss this here. I mean, I'm not saying I'm going to follow, but I'm going to do a quick straw poll. There should be a way for me to put a poll in the YouTube chat. I don't think there is. Which Z curve? So Z order curve, complex plot, complex function, which is like Z equals X, is Z equals X plus Y times I kind of, is that right? And then Z curve, like genomics or something, and then spin again. I'm going to allow multiple choices, which is a little weird, because I want people to be able to don't just everybody pick. Yeah, maybe I won't allow more. I don't think I'm going to pick spin again. I feel like I cannot go against the wheel. Like, I've made a choice in my life, and that choice is to follow the wheel. So maybe I should just take spin again off. I'll leave it on there. Just see what happens. I allow multiple choices. I'm going to allow more. Let's try this. Yeah, Z order curve sounds really good. One choice. ASCII art is interesting. F of Z, where both Z and F of Z are complex. The colors are used to show phase. All right, no multiple choices. I'm creating this poll. There we go. All right, somebody will kindly post this into the chat for me. Will somebody kindly post this there? I guess it'll take a minute. And we'll move on. Let's see if I can post it. Okay, I'm a little bit afraid to look at the results because I hear that spin again is winning. No, I'm not spinning again. I just wanted to know if that's how you felt. See, the thing is, though, if you add up all of these, all three of these are beating spin again, right? So technically speaking, spin again is not winning. It's like losing by quite a bit. Spin again has to be more than 50% of the vote for it to win. I'm making that rule right now. So I'm picking Z order curve right now is winning as far as I'm concerned. Because my assumption is that anyone who picked these two is picking Z order curve as their second choice. Okay? Just so you know, you've got, spin again has to have a, what's the word? It's a plurality, but it actually has to have a majority. When it's going down. Come on, Z order curve. Well, I know how to fix. I know one person who can. Oh, whoops. Yeah, I can vote here. I've got a vote just like everybody else. All right, we're gonna give this another minute or two. Z order curve with the Hilbert curve. Ah, okay, is that a thing? Whoops. Ah. So they're related, yes? Oh. Well, there we go. Oh, look at this. Oh, well, we're doing this. Look at that. Okay, we're doing this. It's been decided. We're talking about the wheel has spoken. Yes, that's why Spencer says that's why you should have allowed multiple options. I know. That's why I wanted to allow multiple options. But everyone said, no, one option. Oh! This is exciting. You can all blame Dayton Guy 246 for this. All right, doesn't seem like people are voting anymore. No. Only spin again has to get to 50%. No one else has to get to 50%. First of all, Z order curve is 1. It's too late. Z order curve has 1. But the reason why is I should have done 2 votes, like spin again or one of these 3. So I'm adding all 3 of those up. If they're greater than spin again, then I'm picking the one of those 3 that has the most votes. So we're good. Z order curve / Hilbert curve. I'll look into it. I mean, who knows if I'm even have time to do this weekend. This all might be moot. But that's what will be in the next Coding in the Cabana video. So I'm going to play my goodbye song that I haven't in quite a while. I'm going to play a little tic tac toe against my friend, the tic tac toe player. Where is it? All right, I'm going to win. And if there's any last questions, wait a second. So, Hilbert curve, 3 blue, 1 brown. Yeah, I would say so. Violet saying, posting that there is a, oh, look at these, space filling curves, Hilbert curve. Yeah, so this is great. If there is a 3 blue, 1 brown video, oh, and this is just a montage. Oh, so satisfying. Okay, I mean, hello. Have I just totally ruined 3 blue, 1 brown's beautiful video here of space filling curves? You can't really hear the music. You probably hear it quietly. Hold on. Let's fix this for a second. Sound. Okay. Yeah, I mean, we're doing this. And then there's also a Vihart video. Okay, this I definitely want to do. Flow snake. Wow. Oh, this is so ridiculously satisfying. I'm very excited about this topic now. This is awesome. And then there was also a Vi Hart video on this. Someone will share it with me. I don't want to find the wrong things by accident. Oh, this must be it.
Maybe you like to draw squiggles when you're bored in class. Somehow the wandering path of the line echoes
from
the
2011.
of the teacher, perfectly capturing the way it goes on on about the same things over and over, but without really going anywhere, and a deep display of artistic metaphor.
How am I not subscribed?
But once you're better and bored doodling,
am I logged
you learn
in
that
as?
some squiggles are better than others.
How am I not
Really
subscribed to
fill out
Vi
the
Hart?
page,
That is
squiggling around
crazy.
themselves as densely as possible in a single line that doesn't cross itself. It's like the ideal would be to sit down at the beginning of your least
These are
favorite class,
so
put your
good.
pencil on the page, and keep drawing a single line, filling
Yeah,
up
vintage
more and
Vi
more space
Hart.
until
Okay.
the bell rings.
Okay, it has been decided. This is going to be a great topic. I'm excited to give it a try. And we'll see you all next week sometime, I hope. I don't know what I'll be doing next week, but hopefully I'll be getting to this in Coding at the Cabana. Any last questions before I go? Feel free to ask. So Lars asks if you can suggest things. So one of these days I'll have a better system for this, and it's something that the community is always thinking about. At present, the way to suggest a topic, there are really two approaches. Well, there's more. There's the Rainbow Topics GitHub repo where you can file an issue with an idea. I will definitely see that, and people in the community will see that. You could join as a member or a patron, and then we discuss ideas in the Slack channel, which I'm moving to probably a Discord soon enough. And then those are the two main ways. You can also tweet me at Schiffman on Twitter. I read all my mentions. Where is the full list of coding challenges in text form at asks 623? So that's a good question. I don't know that there is just a text form, text version of the list, but all the coding challenges are on the website, and you can find them here, and you can see me scrolling through them. Some of them are multi-part, but here they all are on codingtrain.com, thecodingtrain.com/coding challenges. So Styx is asking if I have a current Discord chat. There is a unofficial Coding Train Discord that you can find and join. I have a patron community that's on Slack. I'm thinking of kind of combining those, but having a member-only Discord. I don't know how to do it, what to do about that, but yeah, that's what's there currently. I'm thinking that I'm going to move to having a Discord for the member community, and then there might be like one open channel on that's just open, and the rest would be private for members only. I'm not really, that's kind of my current thinking. It's something I'm working with Sai on. Lucas asks, can you make a search bar for the challenges? That would be a nice feature for the website, potentially. I don't know that there's that many that you really need to search. There are quite a few of them. I would say if you just look for, if you do Coding Train Challenge and then type what you're looking for, like, if I typed fractal, for example, that's usually you're going to find it just with a Google search or your search engine of choice. Thank you, Andrew, for your nice comment. A Python series, that would be nice. There's only so much time in the day, the week, the month, the year. All right, thank you, everybody. I'm going to switch over to the wallpaper where your name will pop up if you subscribe as a member. And leave this going for a little bit while I stop all the recording and upload all the footage. Have a wonderful holiday. Jonas asks, when is your next live stream? Let me answer that. Probably Thursday or Friday, December Is that 5th or 6th? I'm not sure. Sometime next week. I don't have a regular schedule right now. I think in 2020 I'll be able to have a regular schedule, and probably won't be on Fridays, but stay tuned. Bye, everybody. Mwah. As always, I always forget the this dot, this dot, this dot, this dot. I'm gonna do this dot, this dot. I'm gonna do this dot, this dot, this dot. I'm gonna do this dot, this dot. I'm gonna do dot, this dot, this dot, this dot, this dot song. This dot, this dot, this dot. Never forget the this dot, this dot, this dot, this dot, this dot song. This dot, this dot. Never forget this dot. This dot, this dot, this dot. I'm gonna do this dot, this dot. I'm gonna do this dot, this dot, this dot. I'm gonna do this dot, this dot. I'm gonna do dot, this dot, this dot, this dot. I'm gonna do this dot, this dot. I'm gonna do this dot, this dot, this dot. I'm gonna do this dot, this dot. I'm gonna do this dot, this dot, this dot, this dot song. This dot, this dot, this dot. Never forget this dot. This dot, this dot, this dot. Never forget this dot. I'm gonna do the this dot, this dot, this dot, this dot, the this dot song. Never forget the this dot. I'm gonna say once again, here we go. Sing it with me. It's the polar Cartesian coordinate song. It's the polar to Cartesian coordinate song. Auto-tune and the internet will fix that for me. Sing it with me. It's the polar to Cartesian coordinate song. 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 So I'm back in the dark just to say goodbye. Thanks everyone, and I am about to click end stream. Mwah!